All right, so we're going to be moving along with our flipped lesson. So here's your first slide of the different properties. That's kind of what we're focusing on today. So go ahead and pause and copy these down, and then when you're ready, unpause. So this first property is the commutative property. These properties should not be new to you, but this one, I kind of want you to have like word association with this. So you think commutative property, I want you to think order. All right, so in the commutative property for addition and multiplication, what this is saying is that the order that you add things does not matter. It does not change your sum, or for this, the product. Down here, the associative property, the word that I want you to associate with that is group or grouping. For this particular property, if you're looking down at these examples, you'll notice that for the addition, the A and B are grouped together. And then on the second one, the B and the C are grouped together. It does not change the sum. And if you look at the examples over to the right, right here, it does not change those values for what you get. So that's what those two properties are. They're very useful. I know that they're not new to you, but you do need to know them, and we will be using them a lot. Here are a couple more properties. So pause and write these down. The identity properties of addition and multiplication, you almost probably think to yourself, these are silly to even call these properties. Well, they're not. They're actually really important, and we'll use them. I even have a couple examples today that will show you where they're useful. Where they become useful is if you do a problem and you're justifying why you're doing it. You may have something like a T-chart, and on the left side of that T-chart you'll have your work. So here's math problem, then this step, and then this step, and so on. But on the right side of that, for every step that you do, you justify why you're doing it with some type of math property. And we'll have problems like this later in the year. It's an important thing to be able to do, to be able to back up what your work is. The zero property of multiplication it's a nice property. It's very helpful as you move up through more difficult math classes, because anytime you get a zero multiplied by any value, it becomes zero. So it's kind of like an eliminating property. It's very, very helpful. This one, multiplication property in -1, says that any number divided by -1 is its opposite. Okay, this negative a does not mean it becomes a negative number, because what if you had the instance where you're multiplying -1 by a negative number? You should recall from your multiplication rules that that would create a positive number. So what this says is -1 times any number is the opposite of that. So the opposite of -4 here in my example would be +4. So here we're identifying properties. It says what property is illustrated by each statement. This first one is the multiplication property of 0. And you could feel free to abbreviate. This one down here, notice that the y plus 2.5 is grouped. Over here, the grouping switches. So when the grouping changes, that is the associative property. You have to be very careful when you abbreviate associative, if you know what I mean. So associative of addition. And then down here we have 10x plus 0 doesn't change the value, so that is the identity property of addition. So here's a couple for you to try out. So pause and give these a shot in your notebook. This first one, hopefully you found to be the identity property of multiplication. This one right here, be careful, because this could trip you up. If you see parentheses and you automatically assume that that's the associative property, you're going to miss problems. What you need to pay attention to here is what is actually changing as I go from this side to this side. So if you notice here, the x is not grouped with anything. I have a y and a z grouped. And over here, those same variables are grouped. But what changes from this side to this side? It's the order. So anytime the order changes, that's going to be the commutative property of addition. All right, the order changed. And you'll see those problems pop up on checkpoints or quizzes and tests that are like that. They're not intended to trick you. They're to see if you are actually paying attention to what's happening in these problems. So just be aware of those kind of problems. Here it says using properties for mental math. A movie ticket costs $7.75, a drink costs $2.40, and popcorn costs $1.25. What is the total cost for the ticket, a drink, and a popcorn? Explain how you could use this by using middle math. So the problem reads, I have the price of these 3 different items, so there's the price of my ticket, plus the price of a drink, plus the price of popcorn. If you find a movie theater with these being the actual prices of a drink and a popcorn, let me know, because every time I go, it's like $8 for a popcorn, and if I go with my kids, they have to have it. $1.25 for popcorn would be amazing. Anyway, here we have $7.75, and I could rearrange the order of this problem because of the commutative property to make it a little bit easier on myself. Hopefully you've already realized that $7.75 and $1.25 kind of complement each other. They add together easily. 75 and 25 will make it an even dollar amount. So you could rearrange this. Now, I want to expect you to be out at a movie theater if this situation were really going on and thinking to yourself, okay, do I have enough money to do this? I'm going to use the commutative property to add up the prices of the... No, that's not what anybody's going to do. You probably just add them and not think about that. But the reason why you can add them is because of that commutative property. So here we have these 2 values. That's going to be $9 plus the $2.40, which again, this is middle math, so you want to be writing this out, but I'm just doing it so you could see it. And then those 2 numbers are very easy to add together, so you would know the total cost would be $11.40, and you're able to see if you have enough money for that. All right, so writing equivalent expressions. So here I have this first problem. You'll notice that I have the 3 in the end grouped with the 5 on the outside. Using the associative property, I could simplify this expression by changing the grouping around. So I have the 5 and the 3 now grouped together. I can't multiply 3 and n. It just stays as 3n, but I can multiply 5 and 3. And that's why I would change that order. So here, this would simplify to 15n. This one down here has a couple steps. So this first thing is I would need to change the order of this by using the commutative property. So in my parentheses I'd have 7b plus 4 plus 8, and then I would use the associative property to change the grouping. And now I could actually add this problem. So 7b plus the 4 and the 8 makes 12. This problem right here, this is going to be a use of the identity property. So take a look at this one. This first problem right here I could break up and I could say this is the same thing as 6x times y. All right, and I just put a dot there to kind of bring that off to the side. And then down here, what I'm going to do is use the identity property to rewrite that y. In other words, if I multiply that y by 1, it does not change the value of that. Okay, and then from here what I could do is split this into 2 separate fractions, because if you recall, when you multiply fractions, you multiply straight across. So I could break this apart into 2 separate fractions. So I'd have 6x over 1 times y over y. And for those of you who are confused, just look over here real quick. I would have, for instance, if I had 1/2 times 3/4, this is the same thing as 1 times 3 over 2 times 4. Okay, I can move those things like this. So if I could go from here to here, I could also go from here to here. That's what I'm doing as I go from this to this. I'm splitting that up. And then here, hopefully, you see that this y over y is something that divides out. Anything divided by itself is equal to 1. So this then becomes, I'm going to come up here so I have room. I have 6x over 1 times 1. And anything divided by 1 and multiplied by 1 is itself, so this would simplify to 6x. So I know that was a lot of steps to do this, and ultimately your goal, and we'll be looking at these in more detail later in the year, is to be able to simplify this very quickly without going through these steps. But these steps show you why you can. Some of you probably remember from last year where you could take this and just cross both of these out and be left with the 6x. But there's a reason why you could do that, and that's what all of this is about, is the reasons and the math properties behind it as to why you could do that. Okay, so go ahead and try simplifying these expressions on your own. So you'll want to pause and do these problems. This first one hopefully you found to be 9.45x. This next one right here, hopefully you got to be 4h plus 9. And on this last one, that is 2 over 3n. And if you had a hard time on any of those, make sure that you're asking me in class about those. All right, last couple things for today is using deductive reasoning and counter examples. So pause and write down these vocab words. Deductive reasoning is the process of using logic from facts to come to some type of conclusion. So based upon what you know, you have actual facts in front of you, is deductive reasoning, and you create a conclusion from that. We'll talk later about inductive reasoning, and that's where you're kind of making inferences. You're using clues to things, but you don't have the facts directly in front of you. But for now, we're just looking at deductive reasoning. An example that shows that something is not true is called a counterexample. So here's how we might use this. It says if the statement is true, is the statement true or false? If it's false, give a counterexample. So right here it says for all real numbers, a and b, a times b equals b plus a. Now hopefully you realize that that is a false statement, but in order to prove that it's a false statement, you would need to assign some values to this. So some really easy values would be a can be equal to 2, and b would be equal to 3. 2 times 3 is equal to 6, and then if I come over on this, 3 plus 2 is equal to 5. And those two things are not equal to each other, so that would be a counterexample. For this one, this says for all real numbers a, b, and c, this must be true. And this is true. We have a couple of examples. First of all, the order changes here, and then the grouping changes. So this is true because of both the commutative property and the associative property. But all you would need to say is, yes, that's true. And that's it. So I'll see you in class.